For our thermodynamics PVT experiment, we'll be demonstrating how volume expansion relates to a change in pressure in a controlled volume. So our system right here is a 20 milliliter syringe, and in the syringe we have installed a cap. This ensures a closed system. As our control volume will be filled with 5 milliliters of water, we will apply a force to displace this 5 milliliters to 10 milliliters. With the knowledge of that force, we can determine the change in pressure using the pressure equals force over area equations. In this experiment, we will be using the ideal gas assumption for the water and air inside of the controlled volume. We'll be also following Boyle's Law's principles. The prediction for our experiment is that there will be a change of negative 82,920 pascals within our control volume. $300 milliliters of water. Total water in the bucket is 2,600 milliliters.
Here we've got the force calculations for our system. Hang on, can we see that? There we are. So at that's V1, we've got 300 milliliters. Delta Y is just the change in the volume. That's 0.5 milliliters, and as you can see, it just keeps going. We add a little bit more water each time to the bucket, and then eventually we got down to our target delta Y, which was 5 milliliters of displacement, right? And so the force F equals mass times the gravity, and due to the fact that down here, if you've got the specific volume of water equals 1.0 liters per kilogram, that means it also equals, by this math right here, it equals 1 milliliter per gram. So therefore 1 milliliter H2O equals 1 gram H2O. So with that assumption, we can take that up here and say 300 milliliters equals 300 grams, which is also equal to 0.3 kilograms. You times that by the acceleration due to gravity, which is 9.81 meters per second squared, and you times that and you get 2.943 newtons. And you just do that for every single one right down here, and that gets you all your forces at each different volume of water in the bucket. The mass of the bucket is negligible in this instance here. And then to find the pressure, we simply take the diameter of the syringe, which was 2 centimeters, and we take it and we convert that to meters to keep it all in SI units. And so here we just take each corresponding force right here, you plug it into this formula, pressure equals force divided by area, and from here you take this, divide it by the formula for the area of the syringe, which is a circle, so you use pi over 4 times the diameter, which is converted to meters, and you square it. Then you do this for every single one, and you've got 9,367.86 pascals.
The final results for our experiment was the 5 milliliter volume expansion created a change in pressure in our control volume of negative 81,188 pascals.